Welcome back, students. In this class we will be studying about parametric equations. Now you have to understand what is a parametric equation. Now if you are able to find x which is function of t and some y which is also a function of t, in this case I have to write it as g of t, and these two x and y together will describe the curve. Okay, so that is what we call it as a parametric equation, because the t which we are using is the parameter. Okay, now sometimes we will use t, sometimes we will use theta. So it depends upon the requirement that we are faced with. Now, having given this, now you have to understand that parameter equation or parametric equation always reduces the variable in question. One particular important aspect in the system. So they will always reduce the variable in the system. So this means they can be easily solved. Solution can easily be achieved for the given system. So having made these basic things, we will have to go into understanding the concept. So what we are going to do is we are going to talk about the parametric equation of the circle. So let me write that down. Parametric equation for the circle. We're going to be talking about x squared positive y squared is equal to a squared. Now if we were to draw the circle, this is x-axis, y-axis, then we got a circle like this. This is origin O. Now we take a point P of x comma y. This angle is theta, and we drop a perpendicular. This is m. The distance, or in other words the radius, is a, so we write that down. So this is a typical circle. Now for this, what we're going to do is we already have a perpendicular, so this is 90 degree. So we will make the following assumptions. So OM be equal to, in fact the x component is always cos theta, the radius is a, so clearly I don't need to make an assumption. So clearly OM is equal to a times cos theta, and MP is the vertical component, is going to be equal to a times sin theta. So we have got this. Now this can be a parametric equation. In fact, let me write it down. This is a parametric equation for the circle if it satisfies the equation of the circle. So that is the necessary condition. So what we are going to do is taking, this is OM, so taking x is equal to a times cos theta, and MP, y is equal to a times sin theta, and substituting them in 1, this is taken as 1, we get, so what do we get? So this is a cos theta raised to the power 2 positive a sin theta raised to the power 2 is equal to a squared. So this is a squared cos squared theta positive a squared sin squared theta is equal to a squared. I take a squared out, I would get cos squared theta positive sin squared theta is equal to a squared. Cos squared theta plus sin squared theta is 1, so I get a squared is equal to a squared, meaning left hand side is equal to right hand side, which in turn means the parametric equation satisfies the equation of the circle. Okay, so that is a good aspect. Now this is only one part. Now there is another part we have to look in. Conversely, we will have to check. So from top to bottom, it is okay. But now we have to check from bottom to top. This is also okay. You catch my point. So now our starting point is from the bottom. So how are we going to do that? Now we know that, so let me write that down. We will now show that if x is equal to a cos theta and y is equal to a sin theta, we are getting a circle. We are getting the circle. So consider x is equal to a cos theta. So this means x over a is equal to cos theta. Also consider y is equal to a sin theta. So this means y over a is equal to sin theta. I take this as 2, I take this as 3. Now squaring 2 and adding with 3, we get, so what do we get? We get x over a squared is equal to cos squared theta, and y over a squared is equal to sin squared theta. We are adding these two. So this is going to be x squared over a squared positive y squared over a squared is equal to cos squared theta plus sin squared theta. I take a squared out, I would get x squared positive y squared is equal to cos squared plus sin squared. But this is equal to 1. So I've got x squared positive y squared with 1 over a squared as a multiple. I can move this out. So this would mean I got x squared positive y squared is equal to a squared, which is the equation of the circle. So truly x is equal to a cos theta and y is equal to a sin theta is indeed the parametric equation or parametric form of the circle x squared positive y squared is equal to a squared. That completes the solution for this question.